They are on YouTube, which I think most of the InfluxData talks are available from previous InfluxData talks. Today's talk is going to be actually a little bit different. I want to talk specifically about some things internal that vary between 1.x and 2.x. Because I think when Tim asked how many people here had used the 2.0 alpha, not too many hands went up. Is that right? Well, I hope that we can change that, and I wanted to kind of give some expectation of what you might see different as a user and operator of the system. So, does this button do anything? Also, there are 2 more talks today, and you're lucky that mine is only one of them. And anyone who arrives late, you can just tell them that they missed the good part. So, oh, Mark gave me a wrong clicker, typical marketing guy. So, I know, it's just, yeah, I give the engineer the wrong clicker and then just look at him. That's good. So, all right, so here's what we're going to talk about today. 2.0, key differences between 2.0 and 1x. Some of these things you've seen today a little bit. I hope to talk about them in a slightly different point of view. I want to talk about our path to the 2.0 open source beta, what we've been releasing so far. We've been calling an alpha. It's not yet feature complete. I want to talk a little bit about some of the 2019 database internals. So I'm responsible for the teams that are responsible for the database. I want to talk about some of the focuses I have as a point of emphasis on the database side. And then I want to talk a little bit about what we're doing with 1x, because there's been a lot of talk here about 2x, but everyone's actually using 1x, and I think it's important to talk about that. So, tick, stack, toe. I was a little punchy when I made these slides. I'm going to warn you. Also, it turns out I can't see my speaker notes, which is a little bit annoying. Yeah. So there's been a lot of talk about how the tick stack has been combined into a single platform. That's all great. I want to talk about what some of the impacts of that might be on you as a user of the product that perhaps you haven't thought about, and what some of the impacts might be on community members that are participating with us, specifically through GitHub. So while the UI and the scrapers and the tasks and the database are now all in a single process within the open source offering, that's great. It's easy to use. It's easy to get started. There's not a lot of management between the different components. However, they're all in the same process. That means that if you're used to monitoring InfluxDB as the database, and there's certain things that you track, like thread count, CPU, I/O, these behaviors are going to look different now. The database process isn't just the database process. It can include things like the scrapers, right? You'll see outbound I/O potentially to scrape targets originating from the database process. The UI is there. If you're used to kind of looking at Go stacks or Go routine traces to kind of understand the health of the process, you'll see a very different profile of activity. Also means that when you come to interact with us, you're no longer interacting with us on the community perspective, perhaps in our capacitor repo or our chronograph repo or InfluxData repo, but all of these things are now participatory within the InfluxDB repository on GitHub. And so the community from these different projects is being brought together, and so we'll have to develop some new ways of triaging and making sure that we get the right information to the right people and continue conversations in a way that's clean. So I want to make people kind of think about that a little bit and kind of understand a little bit about what's different. And I'm sure that we'll have a lot to learn together as we go forward on that. So another thing that's really quite different that's been talked about a little bit today are the fact that continuous queries are no longer present in the 2.0 side, and they've been replaced with tasks. At present, tasks is basically Flux plus cron. But there's a much broader vision for that. The idea is that no one's really happy writing a continuous query, or I should say very few people are happy. They're hard to write. They're hard to debug. It's limited in scope, what you can put into the query, whereas a Flux script is almost more like a 4GL language where you can combine multiple queries together with intermediate data processing, right? Much richer query analytics. These continuous queries are particularly hard to manage when they fail. It's difficult to know what they fail, perhaps what period of time was failed. It's not how to recover that. Tasks are much more verbose and structured in how they log their runs and their activities. So just a much richer infrastructure. There's also lots of places within the system where you want to be able to run some bit of query according to some incoming signal. It's basically kind of what alerting is, right? And so the alert systems will be built on top of the task infrastructure to a large extent. So while continuous queries are going away and the replacement looks quite a bit different, our goal is that we can create a rich task authoring experience, debugging experience, and operational experience, and that we can, instead of investing in a combination of capacitor workflows and continuous query workflows and external query sampling and alerting, that we can put a lot of sort of kind of wood into this one kind of more consolidated arrow and create a more general experience. Over time, right now, as I said, Flux and tasks look a lot like Flux plus cron, but I kind of encourage my team to think of it almost as Flux as a service. Right? The idea is that you should be able to submit a unit of Flux, right, a unit of data scripting to the database, and you should get it to run on a trigger of your choice. So right now, those triggers are very time-oriented in a cron style. In the future, those triggers could be oriented more towards an alert consequence or perhaps the output of another script for chaining, right? So right now, it's tasks, Flux plus cron, but in the future, we're really looking forward to how we can create a really rich ecosystem of work around tasks. The legacy 1X products, they had a number of different APIs that were different for every product, right? Capacitor exposed a REST API, Influx open source exposes an API, the meta nodes expose an API, and none of those APIs were documented, which is not a criticism at all of the documentation team, which would desperately like to document them. It's completely a criticism of us, the developers, who created them in a way that was perhaps a little ad hoc. So another major difference here between these two platforms is that you'll now see a consistent API across all the different offerings, and that API is a much more primary way of interacting with the system. So in 1X, if you'd like to create a database or a retention policy, there were certain DML actions that you could take directly from Influx QL, right? These are all API-driven, although they can be presented as in the command line, right? So you can still do it from the command line, but the command line is just a wrapper around the API. And so getting used, I think, to this API orientation is something that'll be a little bit different for people who are used to operating the older system. Something else I want to talk about is that we don't really have a single user model within InfluxDB 1X, open source, and enterprise. It varies. And that user model combines a lot of different concepts, right? There's databases, retention policies, there's a permission set in open source, there's a separate permission set in the enterprise side. And the enterprise side, there's a feature called fine-grained authorization, which is really a response to trying to make it possible to meet user stories that we weren't able to meet with the existing permission model. It's all honestly a bit of a mess, right? And so the idea is to take all of these disparate user models and to consolidate them into a model that's much simpler. So you have an organization, a bucket, a user, and a user has permissions to various activities, right? And so that simple structure, org, bucket, user, replaces really all of the auth-z modeling that went around DB and fine-grained auth and enterprise auth and open source auth. It also means that the user model and the auth model is now consistent in 2.0 from product to product in open source and enterprise, and is transportable between the two, which is not the case right now in OSS 1X and 2X. And I'm sorry, OSS 1X, and there's too many version numbers, and Enterprise 1X. All right, here's one of my personal favorites, _internal. How many people here use the _internal database to monitor Influx? I think most of you do. How many of you have looked at it and thought, what devious mind framed this horrible construct, all right? Because it's full of things. Yes, Sebastian has probably thought that. Well, these devious minds have tried to organize a better way forward. Instead of having an internal database, and by the way, it's also fascinating when we look at Influx cloud instances, oftentimes the internal database is one of the busiest databases on those instances. There's quite a bit of overhead. It can be quite expensive to run. And the worst kind of defect to fix is a customer outage because the internal metrics database had a defect and triggered like a horrible compaction, which I'm sure some people have seen. So this is motivated by user experience. It's also motivated by trying to remove work off of the system that shouldn't be there. Don't monitor your monitoring system with your monitoring system. And motivated by trying to make it easier for people to understand clearly how to monitor and manage the database and the entire Influx combined product. So the database, InfluxDB, it now exposes Prometheus-style metrics. All of these metrics are organized in either use or red-style shapes, depending upon exactly which service is exposing the metric and which model is more appropriate. And these will be supported as an API, or we'll be careful about changing these. We'll document how to use them, expectations about what they mean, and this will be a full replacement of the internal database. However, this also means that unless you actually take the action to scrape this and to write them back into a database, that you won't have persistence of these metrics implicit in Influx over time. Right, so you'll have these metrics that'll be scrapable. You can scrape them with another Influx instance, right, with the scrapers are built in, and kind of have your own external monitoring system. Or you could configure scrapers to scrape them and write them back into the thing that was just scraped, but we don't really suggest that. But this is one change that you should be aware of if you're used to running Influx and you want to try to play with the alpha a bit. All right. So here's more of a, I'm talking really quickly, looking at the time go by. I'll slow down here. I think it's a long day of talks, and I kind of talk fast. So out-of-time partitioning. So 1.x is a time partition storage system. This means that as we collect and store data, we put that data into shards, and those shards are for a specific period of time, and those shards are the actual physical files on disk. So if you look at an Influx database disk hierarchy, you'll see a number of different directories. Those directories store the time series data, and each of those directories, it covers a specific range of time, right? So when I say that it's time partitioned, I mean it's basically the database kind of self-shards itself on this axis of time. And it does that based upon the retention and database combinations that you specify and on the shard group durations that you specify. So this is good and bad and also a little bit indifferent. It turns out that it's not a huge win that you might think it is for a number of reasons. It also turns out that there's some surprising penalties to it that you might not understand at first. And so all of these are motivations for the changes that we've made. So first, what's nice about it? Well, a lot of these systems obviously keep a moving window of data, and being able to evict the time series data that you don't want by simply dropping a directory off of your disk is super cheap. However, when running the in-memory index system, that in-memory index isn't per shard. It covers all the shards in the system. And so while it was cheap to evict the actual time series data from disk, it still meant manually walking through those indexes and removing the data from the index. So it's not actually as cheap as it sounds, right? It's sort of I/O cheap, because you don't need to recompact and remove that data, but it's not as computationally cheap as it might seem, because you actually have to go and then update the indexes that are all in memory. So we thought we'd be super clever when we invented TSI, and we would store the index also on shard boundaries. So for TSI, indexes are actually per shard. This means it's really easy to throw them away. However, it's quite expensive to create them. So if you're running a TSI-based service and you see a shard rollover point, you'll often see the system slow down as it needs to do series creation for the new TSI index. Creating a new entry in the index is substantially more expensive than checking to see if an entry is there and can be reused. So as new series show up in an empty shard, every index has to go through and recreate all the different measurement and series mappings as it discovers them as the shard is being filled. So that's also not a great win. Secondly, in part because of the user model, people often wanted to use a database to have a logical meaning and not just a physical meaning, right? They didn't want the database just to demarcate some amount of storage on a disk, but they wanted to use the database to separate the different permissions that a user might have. This led people to create sometimes thousands or even tens of thousands of databases as they would try to align databases to something that was logical to their organization or application structure. But since each database retention policy in shard is in a way its own little mini database on disk, that creates really horrible I/O patterns, right? And so in the current 1x operational advice, we advise you to limit the total number of databases you have to some pretty arbitrary number like 10 or 15 or 20. We don't say that because 20 is a magic number. We say that because we're trying to advise you that you shouldn't create hundreds of them, because when you create hundreds of them, you destroy all of the I/O patterns by having a large number of files that are all active at the same point in time on disk, which defeats the sharding intention or the time partitioning intention to begin with. So all of these things have been replaced by the concept of a bucket. In a bucket, all buckets live in essentially one shard. And the system no longer maintains retention by evicting a shard out of a shard group, or I'm sorry, out of a retention policy in a database when its time expires. Instead, it runs a delete logic, and it actually just basically deletes the data that needs to be deleted. Now, this system may prove to be more expensive. We have some more testing to do, but it's actually abstracted between the logical and physical layers in a way that we can still add like per bucket physical storage if we chose to. Right? So we could compact data during the compaction process to a per bucket basis and then continue to maintain that on disk for historical data to make its eviction easier. However, it gives users the logical abstraction with a bucket. We can support tens of thousands of buckets if you prefer. That wasn't possible with databases. And when you really dig into some of the different cost models for the retention policies as they were laid out at present, I hope the explanation kind of helped to clarify they weren't really clear wins anyway. So this is another major difference, and it's also something that you'll probably notice as some interesting performance differences. If you see these, we'd love to hear about them. It's a pretty large change. So 1x has two index types. There's an in-memory index, and there's TSI, which is an on-disk index. In 2.0, we will only support TSI. The in-memory index will not be supported in 2.0. We actually would have liked to have made this change substantially earlier. It'd be nice for us to only have one index type. We see that the TSI index performance is now very much on par with in-memory. It offers other advantages. However, since an index for TSI is on a per shard basis, the in-memory index covered all the data, it actually makes the migration process kind of a hassle to automate. And so for the moment, we've allowed people to either kind of choose which they want, either opt all of their shards into TSI with an operational procedure to create indexes for the legacy shards, or to continue to running within memory indexes. But going forward in 2.0, TSI will be the only supported index type. All right, so we've heard a ton about Flux and InfluxQL and PromQL and Apache Arrow. The point that I want to stress here is that while the Flux syntax is pretty, the syntax isn't really like the strategy for me, right, for the team. So really what we want to do with Flux is create a language that allows integration across a broad number of ecosystem components, right? All of the interesting talks today, meaning all of the ones that were given by people not from Influx, basically, they all show a large amount of ecosystem integration, right? Everyone is taking many different systems, combining them together. The talk from Oracle was right on point, right? Using Influx essentially as a facade in front of a large number of other data collection systems. That's the goal for Flux. All right, and so we will support InfluxQL on 2.0. However, it'll be supported by transpiling InfluxQL to Flux, meaning that there will be no longer the InfluxQL query engine that exists in 1.x. There is really only the internals of the 2.x query engine. However, we will convert InfluxQL to Flux. We've actually done a ton of work on this. We've have converted and tested many of the queries that flow through Influx Cloud. And so we have a relatively working transpiler, and we'll be integrating this into the open source alpha shortly. There's also work going on to be able to transpile PromQL along the same pattern. So if you would like to write a Prometheus query, then we'll be able to support that. And we'll continue to invest in the Apache Arrow project, where we intend to be able to make more and more of the data available through Arrow interfaces over time. So goal for Flux isn't so much about the syntax. It's really about being able to express richer queries that combine multiple interactions with the database. It's about being able to produce a single, internally stream-oriented, kind of guardrailed query system that we can then combine lots of different syntaxes, transpile lots of different syntaxes to. So this is obviously another major difference. However, if you're using InfluxQL on 1x and you go to use InfluxQL on 2x, we expect that it should work. However, it is a completely different query engine, and it's likely that you'll see some different performance characteristics. And so that's kind of the main takeaway here from the 1x versus 2x discussion. Some of the CLI tooling. So I don't think this has been discussed much, but there is a new influx command It's also called Influx. So my first advice to you, if you're using 1x and 2x on the same machine, is to check your path to make sure that you have the right influx command. The influx command is really all API access driven. So anything that you can operate against the API for, which includes Flux queries, will run through the influx command. There's been a proliferation of other tools like Influx Inspect. We have some other internal ones that are super useful. They allow typically like direct inspection of TSM or TSI artifacts on disk. All of these tools are being integrated into the InfluxD binary itself. So when you start the InfluxD binary, you can start it to start the server, start the UI and the database and the scrapers and all of that. Or you can pass it a command line parameter and you can actually get access to the diagnostic tools that you might be familiar with through Influx Inspect. The idea here is to maintain two tools. One basically that works against a cluster or a server over a network, and one that works that has to be local, right, to the disk artifacts that it wants to read, and to keep consolidating a lot of the user tools into a slightly more organized hierarchy. So you'll certainly see changes here. There are also a lot of other smaller changes between the two. For example, in Influx 1x, we don't do a lot of UTF-8 enforcement. Database tags and keys are basically just binary strings. It can be anything you want. It turns out that some enforcement here would be really nice. And so we're doing things that would break backwards compatibility to 1x, an opportunity to do that. Probably also introduce float, negative and positive infinity, and NAND, something that's come up from a number of people as first-class types for floats. Again, these will be potentially breaking changes depending on exactly what's been written into your database and what you expected those byte values to mean in Influx. All right. A whirlwind path of what might be different in your user experience between 1x and 2x. So what's the path to beta? So we've been shipping alpha releases. Our path to beta is basically to become feature complete, and these are the major features that are not yet present in the alpha that we intend to make present shortly. So we need to land the Influx QL transpiler. As I said, it's available. It's actually all open source. You can go and read it. You can see it, but it has not yet been integrated with the alpha builds. We have shipped a delete bucket, so we can now delete a bucket, but we have not yet shipped delete with a predicate. So we need to implement delete. A time range delete, basically. And then there's a lot of bulk data migration tooling that still needs to be written, like a bulk import that will allow data to be migrated from 1x to 2x, a bulk export to 2x, and backup. And then I think also really importantly, not just features that are code related, but we have features that are community related. We really need to figure out how to ingest and triage and prioritize. Build some issue templates, GitHub labels. The InfluxDB repository is already very busy. Consolidating all of the Influx work to it makes it even busier. There's some automation things to build like that as well. We ship the alpha on a weekly basis. It has a changelog. You kind of follow this process, but these would be the really major units of work that are remaining from the database perspective that need to land. We develop Flux kind of separately, kind of alongside the other products. We do this on purpose. We would want to build a standalone Flux community that can be separated from the Influx community, right, so that people can be equal partners in developing Flux. It is currently built and deployed on a weekly basis to Cloud 2. It's built and deployed weekly with the alpha release. And then it will be built and integrated into 1.7, which already includes Flux, on a monthly basis. It also has release notes in GitHub. You can see them organized here if you'd like to follow along with Flux. All right. So what are some of the things that I'm focused on, that the database team is focused on internally? So when I kind of sat back at the end of last year, looked back over a lot of different support cases and feedback, I really came up with 4 things that I think we really need to be better at as a database. And so one of them, I think top, is community responsiveness. We've really intentionally run our different tick stack component communities in different ways. So Telegraph is driven almost entirely by its community, right? The code is contributed to Telegraph. The vast majority of it arrives through the community. The database is really, has always been more about collecting issues and feedback, right? Less about code. We also know that we want to build a Telegraph-like community around Flux. We've designed and organized the Flux code base, the Flux language to make it easy to contribute to, we hope. And so we have a couple of community-oriented goals. One, we want to build a Flux community that can resemble some of the richness of the Telegraph community that exists, hopefully has some of similar benefit to the community itself, meaning that people will all have different systems they want to integrate with, different analytic functions that they might want to see, right? Different packages to contribute. Hopefully those lines of contribution will allow easy extension of Flux in an open source way. I want to be much more responsive to community issues that come into InfluxDB. Like our mean time to response for pull requests and issues in the InfluxDB repository, honestly, doesn't please me. It's something that's going to be a point of focus for us going forward. And as we integrate all of these different tick stack components into one InfluxDB repository, myself and the product managers and others will be building processes to kind of on a more regular basis triage these things and to give more community feedback priority into our roadmap planning. So this is not particularly a technical issue, but it's one that I really want to highlight. Delete correctness is another point. There's a slide about that later. I will not speak too much here. Load shedding and backpressure. So in our enterprise cluster, load shedding and backpressure correctness is an ongoing pain point, and this is a point of focus for us. And then improving query resource limiting, right? So having queries that can't your box, basically, is another point. So outside of the 2.0 roadmap, these are some of the internal things that are our focus over the course of the year. You should be able to expect us to improve these. Hopefully, when I talk to you next year, we'll be able to talk about that. So while those are things that I would like to improve, I also wanted to highlight a number of things that I think I've learned over the last couple of years about Influx internals. And I'd like it if you disagree with these to tell me. And if you agree, also tell me. But that's kind of my list of TSM details as I think about what's important to do to move forward with the database. So my first point is that write amplification has never really been a concern that I've heard. So in a lot of systems that are basically like log-structured merge trees, people care a lot about the fact that data gets written to disk multiple times. I've never heard an Influx customer or end user come and ask me a question about write amplification. Instead, most customers are actually willing to trade write amplification for reduced peak utilization of large compactions. All right, so this is something that I mentioned just because I'd like to test this hypothesis that I have. If you think this is not true, I'd love to hear your stories about where write amplification were painful to you. Compaction memory and CPU utilization are often a concern. So you have to have, in many ways, like 2x the total max shard size to fully compact that shard on disk. Requires a lot of memory. It's very computationally expensive. And so while people don't care so much about write amplification, I do see a number of situations where people care about peak compaction performance. We've actually have done quite a bit of work at this in terms of writing more efficient vectorized encoders and decoders for TSM data, which has helped a little bit. But there's still a fair amount of overhead to fully compact a large shard. Backfilling is really common. This actually often piggybacks on top of the compaction. People write data backwards into history more than you would expect. This is actually another argument against time partitioning shards anyway, because in many cases they never really go cold like you'd think they might. I'd like to hear your stories around backfill. And yeah, if you've had positive or negative experiences about that with the database. Range deletes with the predicate are really, really common, right? We talk a lot about these data being append only or write only. That's just not true. People delete all the time for lots of different reasons. And so, as I mentioned earlier, improving the performance and the correctness of deletes is a primary focus. Offline tooling has been surprisingly popular. Maybe this isn't so surprising, but the utility of being able to read and inspect and generate useful information directly from TSM data or TSI data without a running database, something that we found really powerful. I'm curious if others have also used this. It informs some of the priority we give to productizing some of these tools. And I think another thing that I've seen is that TSM space efficiency can be really variable. So the way that TSM files lay out data, they actually maintain an index of all the series in a shard at the end of a TSM file. And so if you have a large number of series within a shard, but each series has a relatively few number of points, the size of this index at the end of the TSM file can actually dominate the size of the metric data that you're storing. So I'm looking for more feedback about TSM space efficiency. As we go forward with 2.0, it's an opportunity for us to change some TSM layout. And so it's just a nice kind of data gathering point.
Quick clarification. I'm not sure I understood what you meant by offline tooling.
Oh. Okay, thank you for asking that. So the question is, I wasn't clear about what I mean by offline tooling. So I mean tools that run against the data in the database without the database running. Right? So we, for example, ship a tool called Influx Inspect that you can point at a directory of TSM files, and it will dump out the series and some cardinalities and counts and other diagnostic information about that. So I mean tools that can be run not with a running database process. All right, tools that can interact directly with TSM and TSI data on disk. You shouldn't run those tools when the database is running, ideally. Well, if you know which ones read and which ones write, you're better off. But yeah, so all right. Delete work. So one of the advantages of no longer having a separate retention policy from a delete policy is that deletes get a lot of attention. So it used to be that delete was a kind of a pretty special code path in 1x, and it had a couple of problems. Its primary problem is that it flowed through the query path and not the write path, which probably just sounds wrong, right? It is wrong. That meant that if you were in an enterprise cluster and you tried to delete data and there was a network partition, that delete never landed in a wall or a journal. It could never be replayed. It didn't flow through hinted handoff. The implementation of deletes themselves had a number of race conditions that have since been fixed. And so if you're curious about some of the types of things that we're doing to make deletes less racy, check out Jeff, also known as the man with the duck head, here on issue 11/586, and there's some pretty cool engineering work that's going on here, so I wanted to highlight that. I included this slide not because it fit in the talk, but because it's Tim's favorite slide I think that I've ever written. This actually kind of goes back to the fact that we don't do so great at backpressuring and at load shedding, and that hinted handoff can exacerbate both of those situations. So that slide is really just a call out for Tim. I know it's his favorite. I have one last topic. I can't give a 40-minute talk, but it turns out I can give 4 10-minute talks if you haven't noticed. So here's my last topic, our 1x release and sustaining model. So our goal, our commitment to our support team and to you is that on a monthly basis, we will ship maintenance releases of 1.7 and 1.6 and on demand 1.5. We still have customers running 1.5. I actually saw someone running 1.3.4, which I think is about 2 years old now, recently. So we're committed to maintaining all important defect fixes to 1.7 and 1.6. If you twist Varesh's arm hard enough, he'll probably get me to backport something to 1.5. I really see people prefer to move forward from that, but we will support it. Chronograph releases are being paired with InfluxDB 1.7 because there's a common Flux dependency between them. So as we go forward and you ship our monthly Influx releases with 1.7, we will integrate a recent version of Flux into that. The current version of Influx 1.7.4 actually has a relatively old version of Flux in it, so there'll be a large jump forward in our next release. Capacitor we are releasing as necessary, so we will spin and release capacitor to fix critical defects. However, it's not on a train release schedule like 1.7 and 1.6 are. And there will be a 1.8 release. I don't think Tim's going to get mad at me for saying this in public. And it'll be primarily a vehicle for our Flux GA. So I have 4 minutes left and time for questions.
Time for another speak.
I could give a 5th talk. It's a good point. Yeah. All right. Well, thank you very much.